everyone. Today, inshallah, we're going to talk about a new topic, which is called recursion. I hope you all saw it in the lecture, and we'll give like a quick revision on it. So basically, when we wanted to repeat some statements or some operations, what we used is the while loop, or the for loop, or the do while loop, or any sort of a loop. And the algorithm which has a loop is called an iterative algorithm, and we repeat steps using iteration. There is another way of repeating steps. The algorithm, the repeating steps, however, will not use a loop, and will use what's called a recursive algorithm. And a recursive algorithm is known by calling the method inside itself. So we'll start with an example, and then we'll see what does that mean. This is an example in the midterm exam of 2015. And in the example, you're asked to write a method that takes a number and returns the multiplication of its digits. And here we call them the method multiply digits. And as you see, it takes as an input an integer, and it returns an integer. So far, this algorithm is written using iterative algorithm. And as you see, there is a do while loop to implement the operation. However, we want to do the same thing, however, using recursive method. So before going through the recursion, just let's decompose the problem. We want to multiply the digits of a given integer. As you see, 145 is one integer. So it's not 1 and then 4 and then 5. No, it's only one integer called 145. So if we want to decompose the digits of this number to multiply it and to get the result, what we need to do is to get the 5. And I hope you know how to get the 5 from the integer. We can use the modulus 10. And then we save the 5 in something, in a variable. And then we get the 4, multiply it with the 5. So we get 20 so far. And then remove the 4 and get the 1, multiply it with the 20. And it's the same as, it's also 20. However, we should multiply the 1 because for another example, it is 245, not 145. So we get another output, which is 40. So to do this using a while loop, it's very easy. You just define your method, which is public static. The turn type is int because you return a 20, which is an integer. And then the method name is multiply digits. And then you give the input, which is, for example, int x. It's an integer, and we call it x. And our result, the 20, the result of multiplication, the variable which is called the result, it starts with, at the beginning, 1, because we will multiply 1 by something, so we need it to be the basic value, which is 1 for multiplication. And then we have the while loop, the do while loop. And what we are doing is we are multiplying result by result times x modulus 10. If you can remember this line, the notation of multiply equal means that result is equal to result times something. Times what? Times x modulus 10. So if you want to write this, we can say that this is equal to result equal result times x modulus 10. Okay? So at the beginning, the result should be 1. Of course, not 0, because if it's 0, everything will be 0. So at the beginning, this is 1. And we have x modulus 10. X modulus 10 for this example will give you 5. So far, the result is 5. And then what we need to do is we want to remove the 5 from the input. To do this, we do integer division by 10. And here you see the line, x division equal 10, which means x is equal to x divided by 10. So far from this line, the x will be equal to 14. And then the loop iterates, and then it gets the 4 multiplied by the 5, and then you get 20. And then we remove the 4. We have only the 1. We multiply it by the 20. So we have 20. And then we remove the 1. And to stop the loop, we have the condition, which is do something while the x is greater than 0. When we divide 1 by 10, and this is an integer division, the result is 0, which means that we will not iterate anymore because the condition will not be true. So we will exit the loop, and then we will turn the result, which is 20. It's easy using loops, and what we want to do is to do the same output, to have the same output, however, using recursion, or to have or using a recursive algorithm, not an iterative algorithm. So basically, in this algorithm, the keyword that made us return and re-execute the operations is the while loop, is the keyword while, right? In the recursive algorithm, we don't have while. Then what do we have? How can we re-execute the operations? It's by calling the method itself. So let's try it. The definition of the method would be the same. So you have public static int multiply digits int x as an input. So we have public static int, it's the return type. And for example, we can call it multiply digits rec, and then we'll give it the input, which is int x. Okay. What you need to do is, you need to know what is the operation that you do inside the while loop, or how can you decompose your problem. As we said, if I have 145, I want to get the 5, right? And multiply it with the remaining of the number, which is 14. However, to have only 14, we needed to divide the 145 by 10, right? And then complete. So divide 145 by 10, you get the 14. This number, you will complete with it in the method. So, okay, we will do this until what? Until the number is 0, right? Like the one here, you have this until the number is 0. So here we do not say until, however, we say when will we stop, when will we return the output, the final result. You always have an if condition, which we called the base case or the anchor case, okay? Which is when we will stop. Let's leave it now. However, if you are not in the base case or the anchor case, then you should have an else statement. And in the else statement, you should tell me when I will continue. Okay, just focus that this method returns something. It's not void method. It's not a void method. So whether it returns an int, a double, or a Boolean, whatever, it returns something, then we should have the keyword which is called return, as we said last time in the methods session. So I should have the keyword return. Okay, good. What will I return? I want to get the 5, for example. So how to get the 5? As we said, the 5 is equal to the number modulus 10. So the number modulus 10, write it as is. It's x, which is the input, modulus 10. Good. And then what do you want to do? What is the operation between 5 and the rest of the number? You do 5 multiplied by something. Then the operation is multiplication. So you write multiplication. And then, so far, you don't have anything which forces me to repeat the steps. Okay? And I want to repeat steps. And I'm not allowed to use a loop, neither while nor for nor do while loop. But what you can do is to call yourself once more. And this is the recursive call. You cannot have a recursive method or a recursive algorithm without a method called in itself. So I'm in the multiply digits rec method, and I will call myself in myself. So I will say multiply digits rec. However, this method, as we see, it takes as an input an integer. It's only one integer. If you pass to me x, then we will not end, because there should be some update for the x. If you see here, the x is divided by 10 each time. You also need to update me the input. Otherwise, I will continue with x forever. So what is the update in our case? What you want to do is to remove the 5, right? We want to remove the 5 from the 145. We want to remove the 5 from the 145. To do this, we said we will divide x by 10. So you send me x, however, it's divided by 10. Okay? Okay. And then when should I stop? When should I return the final result, which is the multiplication of all the digits? I should stop when the number is empty, when there is no number. Or actually, when I multiply something, and this something will lose me the value of the other outputs, which means if the x is equal to 0, if x is equal to 0, then I should return something. Why should I return something? Because, again, the method returns something. It's an int, so I should have the return statement in the if and in the else, because we will go either to the if or to the else. So we will say return, and then return what? If you return 0, then the 0 will be multiplied by all the previous values. So you'll have a value of 0 always. However, I want to say that if the x is 0, return something that will be multiplied by the other values, by the previous values. However, they will not change the value, which means it's the base value for any multiplication, which is 1. Okay? Okay. So far, I have the method which is called multiply digits. However, he didn't call it, which means you did not ask the compiler to go and execute this method. To do this, you should call it in another method, like the main method or any other method, to do the job. So we need to have something like the main method, and it's public static void main string args, and then you open the method. Just take care that the methods are written independently of each other. So you have multiplied digits opened and closed, and then you have the main method. Or you can reorder the methods, it's okay, but what I want to say is you cannot have a method inside a method. Okay? Definition, I mean. Okay. Then here we have the main method, and what we want to do is to call the multiply digits rec method. This method returns an int, so you have one of the two options. Whether you just say system.out.println, and then you call the multiply digits rec and give it the input that you want, for example, 145. Why is that? Why do I put it inside a print statement? Because this method returns an integer or something. It returns something. This something should be stored somewhere, whether in a print statement or in a variable. We will see it later. And we can say something like int y is equal to multiply digits of, and I can give it another value, which is, for example, 234. Okay? But then you need to print the y to see the output. Otherwise, you won't be able to see the output. So we have something like print. We will not print the method. We'll just print the y. So let's compile it. Okay, it compiles correctly, and then let's run. So we have two outputs because we have two calls in the main method. So the first output is 20, which is 1 times 4, it's 4, and then 5, it's 20. And the other output is 24, which is 2 times 3, it's 6, 6 times 4 is 24. However, let's just trace it to be able to know what happened. I will remove the second call. So let's trace it. So here in the main method, we have a call of a method which is called multiply rec, and we give it the value 145. We see, is there a method which is called multiply rec? Yes. And it takes as an input an integer, which is okay. So here we pass the 145. And then we go to the if condition. Is the x equal to 0? It's not. It's equal to 145. So we will not execute the then part. We'll go to the else part. In the else part, you don't have any condition, you just execute what's written. So here we say return x model is 10. X model is 10. The x is 145. X model is 10. You will get here the 5. And then you have the multiplication. Write it. And then you here have multiply digits rec of x divided by 10. This is what? Is this a value? Or is it another call to the method which should be done? So here we have the 5 multiplied by multiply of x divided by 10, which is 14. Is this a value that I can multiply 5 by? Or I should first go and execute and call the method and then see what is the output to be able to multiply it by 5. I should do that because I can't return 5 times something. It's not a value. I can multiply 5 by a call of a method. So what's done is 5 is stored. Do not worry. You don't need to store it in a variable. Stored somewhere. You don't care. You don't know where. You don't care to know where. However, it's stored. What you will do is you will just call the other method, which is the multiply digits. However, you give it a value which is 14. So here I will go and I will call myself and I give the input as 14. And I will check. Is x equal to 0? It's not. Then I will return x model is 10 times the call of the method. This line comes from which call? It comes from this call. So this call only is simplified into x model is 10. X is 14 now. So x model is 10, it is 4. 4 multiplied by multiply rec of x divided by 10. X is 14 divided by 10, it's 1. Okay? And then once more, is multiply rec of 1 is a value that I can multiply by 4 to get the result? No, it's not. It's another method call. Then you should call this method once more. We remove this one. And we now call multiply rec of 1. You see these arrows? This is like with the while loop. In the while loop, I iterate using the word while. Here we don't have while, but what makes me repeat the statements is the call of myself. So here you have multiply rec of 1. Now I will pass the value 1. Is x equal to 1? No, it's not. Equal to 0? No, it's not. Then I will go to this line, which is to return x model is 10. 1 model is 10 is 1. So only this call will be simplified to x model is 10, which is 1, times multiply rec of x divided by 10. X is 1. 1 divided by 10 integer division will give you a 0. And then you will now go and execute this call. Now I will call myself. Multiply rec of x. And x is 0. Is x equal to 0? Yes. Yes, then I will go to the then part and I will return 1. When will this 1 be returned? It will be returned from this call. So only this call will give me the value 1. Okay. Now what do we have? We have 1 multiplied by 1, it's 1. All that is multiplied by 4, then it's 4. All that is multiplied by 5, then it's 20. The 4, the 5, the 4, the 1, they are stored somewhere. You don't care where. However, they are stored. And once you have only values to be multiplied or to do some operation on them, then now you can return the last result, which is 20. That's why here 20 is returned and it is printed. Okay? Okay. Let's do another example. However, in this example, we also use the multiply digits rec method in another method. So let's see what is the question. It's also in midterm 2015, and it's exercise 3B. So here we ask, that persistent numbers are numbers where the sequential product of its digits eventually produces a single digit number. For example, if you have a number which is 764, what you need to do is you need to multiply its digits. So we have 7 times 6 times 4, it gives you 168. So this is one multiplication done for the 764. And then you take the 168 and multiply its digits. So you have 1 times 6 times 8, it's 48. It's the second multiplication done. And then you get the 48. And you have 4 times 8, it's 32. Then it's the third multiplication done. Still 32 is not only one digit, so I have to continue. You will multiply 3 times 2. It will give you 6, and this is the fourth multiplication digit. And then you have 6. 6 is a single digit, you will not multiply anything. So if you want to calculate the persistence of a number, we will do this, and you will say that the persistence for this number, for example, is 4. So let's complete the example. We say that the number of multiplication steps required to reach the single digit, which is 6, number from the given number is referred to as the persistence of the starting number. So the persistence of 764 is 4. Why is that? Because it took us 4 multiplication operations to get to the single digit, which is 6. Okay, so what you're required is to write a method that takes as an integer as an input and returns its persistence. And there is a note that you have to use the method which is called multiply digits, described above, which we performed. With the most, we will not make it with a loop. We do it with a recursive call. So let's just have some examples. For example, here we say that persistence of 764 is 4. Persistence of a single digit is 0. Persistence of 2-digit numbers is 1. And here is the solution if you're going to do it iteratively using a loop. So we need to, what we're doing is we are updating the persistence, right? We first starting with 1 and then 2 and then 3 and then 4. So in the while loop we used a variable which is called, for example, p, and it started with 1. And what we are saying is, I want to multiply at each instance, I want to multiply the digits of my number. To multiply the digits of my number, we will use the multiply digits function or method that we used before. So here we say multiply digits of x, which is the input, and we store it in a variable which is called x, and we are incrementing the p by 1, which means that there is one more multiplication done. And we will do that as long as the x does not consist of one digit, which means it consists of more than one digit, so which is x, here it should be equal, which is x, while x is greater than or equal to 10, which means that we have a number which consists of more than one digit. And then at the end, we return the p. So to do this, however, using recursive algorithm, we will leave the multiply digits rec method, and what we want to do is to define another method, public static, and it returns a persistence, and it's a number, so it's an int, and let's call it, for example, persistence rec. And if you remember, we give it as an input only one input, which is int x, for example. And just want to revise something. This int x does not relate to this int x. They are different parameters. Okay, so you can have int x in both methods. It's okay. Okay, what we need to do is just write the base case at first. And then here we have to return something. We'll come to it later. And then otherwise, if I'm not in the base case, so then I will return something. Okay? In a recursive algorithm, I need to find myself, which is the method called in myself. So, and of course, this call will not be in the base case, because the base case is where I should stop executing. Then the recursive call will, of course, be done in the else part. Okay? Okay, now, what do I want to do? I want to, at each time, if you see the iterative solution, what you are doing is actually you are incrementing the p by 1, right? And you are calling multiply digits in the persistence method. So to increment the p by 1, here we need a variable. However, in the recursive algorithm, in this example, you don't need a variable. You just need to add 1. Increment 1 means add 1. So I will add 1 manually, which is I will return 1 plus something. Okay, 1 plus what? As a definition of the recursive call, I should see something like persistence rec. Okay, good. And it takes an input. Okay, this input, is it x? No, it's not x. Why? Because you do not actually pass, in the example here, you do not pass 764 in each time. You have 764 at the beginning, and then you pass 168, right? What is 168? How did you get the 168? The 168 is got from the multiplication of 7 times 6 times 4. Okay, how can I multiply 7 times 6 times 4? You have already implemented a method which is called multiply digits rec, which does the job. So what you will do is, you will not say persistence rec of x. However, you will say persistence rec of 168, which is returned from multiply digits rec, which is this method. And this method takes as an input an integer, which is x. Why is x? Because if I want to get the 168, you pass for me 764. Okay? So, okay, here I will say return 1 plus persistence rec, which is this method, of multiply digits of x. Here, the recursive call is not multiply digits of rec. However, it is the persistence rec. However, in this example, what we need to do is to call another method also in the persistence rec. Okay? Good. I will continue adding 1 till when? I should stop somewhere. Where should I stop? I should stop when the number consists of only 1 digit, right? Because in the example here, we have something like persistence of 2 is 0. So there is no persistence if the number consists of only single digit. How can I check that? You can check that by if x, which is the input, is less than 10. This line means what? This line means that the x has a value of something like between 1 and 9, okay, or 0 and 9. So if it's only 1 digit, what do you need to return? You don't need to return 1. However, you need to return the value which you expect, which is 0. So here I will say 0. Okay? And we'll trace it to see what's happening. However, so far we have the persistence rec. Okay? However, it's not called to be executed. Where can I call it? You can call it, for example, in the main method. So here I will say persistence rec of, and for example, let's do the 32 number. However, this method returns an integer, so you need either to put it inside a print statement, .out.print, or as we said, store it in a variable and then print this variable. Okay? So let's compile. Okay, it compiles correctly, and if we run, we have the value of 32, which of 1, sorry, which means that this number is multiplied or has the persistence of only 1 And why it's 1? Because you have 32, you multiplied 3 by 2, you have a 6, and then you will stop. So you only multiplied once, so you have the persistence of 1. Let's trace this, this call. So here in the main method, we call the method with an input of 32. Then we go, is x less than 10? Is 32 less than 10? No, it's not. Then I will go to the else part. Here it says something like return 1 plus something. Then it's 1 plus something. Is this something a value that I can add to the 1? No, it's not. It's a recursive call. Then I will say persistence rec of what? Is this a value that you will pass to persistence rec? Or is it another method call, which is called multiply digits rec, that you will need first to perform? And this method will return you an integer, and this integer will be passed here. This is the case. So what happens is, here we call multiply digits and we give it 32. So we will find, is there a method which is called multiply digits that takes as an input an integer? Yes, here it is. So we will pass here the 32. And then it checks, is x is equal to 0? It's not. Then we'll go to return x modulus 10 plus something. X modulus 10, it's 2. Multiplied by multiply digits rec of x divided by 10, which is multiply digits rec of x by 10, it gives you 3. Now what? Now I have this call. This call actually will call the multiply digits rec. It will not call the persistence rec. So once more we go to the multiply digits rec and we give it the input, which is 3. Is x equal to 0? It's not. Then you will say, this line will say, return x modulus 10, which is 3, times multiply rec of x divided by 10, which is 0. And then we'll go once more. And we'll pass the value 0. Is x equal to 0? Yes. Then we return 1. So this call returns you 1. Now you have 1 multiplied by 2, multiplied by, multiplied by 3, multiplied by 2. Then you return from this line, you return 6. Okay? This 6 is the value which is passed to the persistence rec. So this 6 is the return value from the multiply digits rec. So now we pass persistence rec of 6. Now you will repeat the steps, or you will call the persistence rec, however you give it a value which is 6. Is 6 less than 10? Yes, it is. Then we will return 0. So persistence rec of 6 will give you a 0. You have 1 plus 0. 1 plus 0, is it now a value that can be added and to be returned? Yes, it is. Then we will execute it, and if it is 1, then we will return the 1. And this is the output which is seen in the main method. So here, this call will give you at the end 1, which is printed as we can see in the console. Okay? I hope it was easy. Okay, yeah, we know that the recursion, it has somehow complicated tracing, not like the loops, the while loop, for loop, or do while loop. However, it is easy if you know that when do you need to stop, and if you will not stop, which means you're not in the base case, you need to do something. And what you need to do is you need to call yourself once again. Otherwise, it will not be a recursive method or a recursive algorithm. You need to call yourself in yourself. However, what you need to do for sure is you should change me the input, update it. Okay? It, of course, depending on the example that you are doing, however, you should update the input passed to reach some point to the base case. And in the base case, it's where you exit from the whole algorithm. Okay, because it will return you a value, and this value will be added to the previous values or whatever operation, and then you can have the final result, which is to be printed somewhere. Okay? I hope you have no questions, and this was it for today, and see you inshallah next time. Goodbye.